probability distribution table, uh, the next lesson will be expected value or mean for discrete data. So this is the content that we will be talking about, focusing on expected value mean for discrete data. So once again, this is a topic common to standard level and higher level. So, but you have to watch out for the next videos because I will be talking about the applications of it, of the expected value, and the HL content, which is variance of a discrete random variable. Now, I would like to take advantage of this because this week you will be very busy with your extended essay camp. So I'll just be sending you these videos for you to study at home, study these videos at home, and then definitely there will be questions that I'll be giving for your related to this for your holiday homework. All right, so let's begin with expectation. Let's look at the first example. A die is to be rolled 120 times. On how many occasions should we expect the result to be a 6? So you know that a die has 1, 2, 3, 4, 5, 6. So what do you think? Okay, so since there is 1 over 6 probability of getting a 6, so that means the expectation will be 1 over 6 times 1 over 20 equals 20. So the expectation is we'll be getting 20 times, we'll be getting a 6 20 times. If we roll it, if we roll a die 120 times. What about the next one? Each time a footballer kicks for goal, he has 3/4 chance of being successful. If in a particular game he has 12 kicks for goal, how many goals would you expect him to kick? So this is his probability of being successful. He has a chance of kicking the ball 12 times. So what is the expectation? So you are correct. That will be 3/4 times 12 is equal to 9. In a particular region, the probability that it will rain on any day is 0.28. On how many days of the year would you expect it to rain? Now, assuming that there are 365 days in a year, so, and this is the probability of raining, which is 0.28. So that means the expectation will be 0.28 times 365 days equals 102.2 of the event, while 120, 12, and 365 days, those are the number of trials. Now take a look at number 4. So if the 3 coins are tossed 200 times, on how many occasions would you expect all to fall heads? So what do you think is the probability? The probability of getting a head if 3 coins are tossed, you are correct. It's going to be 1/8. All right? 1/8. So because you only have one possibility and that is head, 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 and the total number of outcomes is 8. So there is 1 over 8. Then times 200, that will be equal to 25. So there will be, so the expectation is 25 times wherein it's going to be all heads, okay, when you're tossing 3 coins 200 times. So in general, if there are n trials of an experiment and an event has probability p of occurring in each of the trials, then the number of times we expect the event to occur is np. So n stands for the number of trials, p stands for the probability of the event. Now let's proceed to expected value or mean. So the mean of the random variable x is called the expected value of x. So mean, you've already heard about mean when we discuss descriptive statistics. So now what about the mean of the random variable x, or it's commonly called as expected value of x? So the notation is e of x, and this is going to be the formula. Expected value of x is equal to the summation of x times the probability of x equals x. So x here in a random variable, this is the value of the random variable, and this is the probability of x being equal to a particular value of the random variable. And we have to get the sum, and then the summation or the sum will be the expected value of x. Now let's have specific examples. Okay, I would like to explain this more, and at the same time I would like to relate this to the mean that we discussed in descriptive statistics. Okay, so let's take a look at this example. 100 professional basketball players are surveyed. Each player has 5 3-point throws at the basket, and the number of baskets scored is recorded in the table below. So if you look at this, this is not a probability distribution table. This is just a mere frequency table. So if you look at the second row, it is the frequency. Baskets 0, 1, 2, 3, 4, 5. So here it means that there are 35 out of the 100 professional basketball players who can do 3 shots, three-point throws shots. Okay, so um, based on this table, how do we get the mean of this, the x bar? Okay, so let's try to recall. It's actually equal to the summation of 0 times 10 plus 1 times 10 plus 2 times 25 plus 3 times 35 plus 4 times 10 plus 5 times 10 divided by 100. So the mean now is equal to 2.55. Okay, now how is it different, or is there any difference if we are looking at a probability distribution table? All right, so actually from this frequency table, you can get the probability. Okay, as I said, 35 out of 100. So that means if you are going to uh, pick in random somebody, a player who can score 3 baskets of 3-point shots, all right, and that is going to be 35 out of 100, right? So for instance here, how do we get now the probability if you pick any player in random who cannot make a 3-point throw or a 3-point shot? So it's going to be 10 over 100, correct? Okay, so that means from here we can come up with a probability distribution table, and this is how it's going to look like. So 10 over 100 is 0.1. 10 over 100 is also 0.1. 25 over 100 is 0.25. 0.35, which is for 35 over 100, zero point 0.1, and zero point 0.1. This is now our probability distribution table, particularly, specifically, a discrete probability distribution table, because number of baskets is actually a discrete data. All right, so that means from here we can now find the expected value, or which is the mean for the discrete data. Okay, now let's go back to that slide wherein it's giving us the formula. Some expected value of x is equal to x, which is the value, multiplied to the probability. So that means the value of the random variable multiplied to its corresponding probability. We just have to do that and then get the sum. Okay, so let's do that for this example. All right, so that means this is the value of the random variable, 0, then multiply it to the corresponding probability, and this is what we are going to get. And what do you think is the answer? The answer is 2.55. So that means looking at these two examples, looking at this example, the mean that we obtain based from the frequency table, based from the frequency distribution, is the same as the expected value for the discrete probability distribution. Okay? All right. So once again, that is our E of x. Okay, remember the notation is E of x, where E stands for the expected value of x. Okay, now let's go to this example. Another example is the random variable x has a probability function. Remember, a, a discrete probability distribution can also be represented as a function, not just in a table. So given by the formula 3x minus 2 over 50, so our p of x is equal to 3x minus 2 over 50 for these values of random variables. So complete the table below to show the probabilities of x. Letter B, use your table to find the probability that x is more than 4. Then C is find E of x. So A and B are questions. If you remember our um, first video, second video, part 1 and part 2 for the discrete, then you should be able to answer this. All right. So okay, so this is how the table will look like. So what is our p of x equals 2? So plug in 2 to the function and this is what we're going to get, right? Okay, so that's 4 over 50. This one is 7 over 50. Plug in 4 to our function. That will be, the result is 10 over 50. And then this is 13 over 50. And this is 16 over 50. Now, for you to be sure that this is correct, so what are you supposed to do? A quick check is by getting the sum of all of these probabilities, and it must be equal to 1. So B, okay, so we are sure that this is equal to 1, right? So B, use your table to find the probability that x is more than 4. So this is more than 4. It is not x is greater than or equal to 4. So which means we're only concerned with probability of x equals 5 plus probability of x equals 6. And that will give us 13 plus 16 all over 50 equals 29 over 50. Now find E of x. E of x again is the expected value, the mean, the average, the expected outcome of x. Alright, so what are we supposed to do? 2 multiplied to 4 over 50 plus 3 multiplied to 7 out of 50, that gives us 21. 4 times 10 out of 10 over 50, that gives us 40 over 50. 5 times 13, that gives us 65. 6 times 16 over 50, that will give us 96 over 50. Okay, so calculate that and we will have expected value of x is equal to 230 over 50. So that is the average, that is the mean. Okay, now let's have another example. So the table below shows the probabilities of a random function x. So find the value of p. So once again, the concept wherein the sum of all of these probabilities must be equal to 1. So you will be able to find the value of p, and that is 0.3. Okay, what about E of x, expected value of x? So 1 times zero point 0.2 plus 2 times 0.25 plus 3 times zero point 0.3, the value of p, plus 4 times zero point 0.05 plus 5 times 0.1 plus 6 times zero point 0.1. So please use your calculator and make sure that you'll be getting or that you get the same answer. Okay, now let's have an exam style question. So this one is taken from a past year paper. Okay, two fair four-sided dice, one red and one green, are thrown. For each die, the faces are labeled 1, 2, 3, 4. The score for each die is the number that lands face down. Write down the sample space, the probability that the two scores of 4 are obtained. Let X be the number of 4s that land face down. B. Construct a probability distribution table for X. Then find E of X. Okay, let's start with letter A. Write down the sample space. So imagine a fair four-sided die. Okay, so we have two of those and then they are thrown. So the labels are 1, 2, and 3, and 4. So how do we come up with a sample space? Alright, so coming up with this diagram, we will be able to have all the possible outcomes. So 1 1, 2 1, 3 1, 4 1, 1 2, 2 2, 3 2, 4 2, up to 4 4. Okay, so counting the number of possibilities, we have 16. So what now is the probability that the two scores of 4 are obtained? By the way, I would like to emphasize this one. When you say write down, that command term doesn't need any calculation at all. Okay? So for double I, just look at the sample space that you come up with, and then two scores of 4 are obtained, we have this outcome. So that means we only have one. Probability therefore is 1 over 16. Okay, moving on. Let X be the number of 4s that land face down. So this statement looks familiar. Okay, that means our X is the random variable, and specifically that is the number of 4s. The number of 4s. Going back to our diagram, the number of 4s. So if you look at this outcome, is there any 4 here? So there's none. So you have a zero number of 4 for this outcome. Therefore, 0 is a value of a random variable. So you have 0, 0, 0. Here, there is 1, 4. That means 1 is a value of a random variable. 0, 0, 0, 1, 0, 0, 0, 1, 1, 1, 1, 1, 2. So you have 0, 1, and 2. Those are your values of the random variable. Okay? And then from that diagram, probability of X being equal to 0, let's try to check. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. So which means we have 9 out of 16. Okay, that will be the probability. Okay, probability of X equals 1. We will have this 1, 2, 3, 4, 5, 6. Okay, so that means 6 out of 16. And probability of X equals 2 is 1 over 16. Since the probabilities are complete, we can now find the expected value of X. And that is by getting the sum of the products of the value multiplied to the corresponding probability. And this is how it's going to look like. 0 times 9 over 16 plus, this is supposed to be 1 multiplied to 6 over 16 plus 2 times 1 over 16. So, sorry, this is a mistake. It's supposed to be 1. Okay? So, but if this is 1, what you'll be getting is equal to 1/2 as well. So the expected value of X is 1/2. All right, so that's it for now. So I only focus on the expected value for discrete data. So once again, expected value is equal to the summation of X pertaining to the value of the random variable multiplied to the corresponding probabilities. So next time we'll be talking about its applications, Okay, and another one is the HL content, which is the variance of a discrete random variable. So that's it for now. See you next time, grade 11s. Okay, goodbye.